Today's video is about polygons. A polygon is a plane figure formed by 3 or more segments connected at their endpoints, and they are named with vertices. I'm going to give you some examples of polygons here. For instance, here is a polygon. Here is another polygon. We name them with vertices. So for instance, if I wanted to call this the vertices A, B, C, D, and E, I could call this polygon A, B, C, D, and E, or I could call it pentagon A, B, C, D, and E. I could call this M, K, L, P. So I would just name that MKLP, and I could just call it polygon MKLP. Some examples of things that are not polygons. Let me show you. So if you had something like this, this is not a polygon. Okay, you don't have a polygon if you've got a diagonal in the middle of it or something cutting through the middle of it. This is also not a polygon. Something that's open is not a polygon. So let's move on. Next page. There are 2 types of polygons. There are those that are convex and those that are concave. A convex polygon has no indentations. So something like this has no indentations in it. Let me draw you an example of something that does have indentations and would be concave. Something, say, like this. This has an indentation here. That is concave. Sometimes it's called non-convex. So let's move on. Next page. We want to classify polygons by the number of sides. If it has 3 sides, it is a triangle. 4 sides is a quadrilateral. 5 sides is called a pentagon. 6 sides, a hexagon. 7 sides is a heptagon. That is an H. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. A couple of different names that I have come across for an 11-sided figure. An undecagon. And I've also come across this name. It's spelled Hendecagon. A hendecagon. 12 is a dodecagon. 13 is a tridecagon. And if you just have n sides and you're not sure what to call it, just call it an n-gon. That's fine. Let's move on to the next page. Now, a polygon is equilateral if all of its sides are congruent. So here's an example of an equilateral hexagon. All the sides are the same. Equiangular are polygons with all angles being congruent. So Here's an example of an equiangular pentagon. Equiangular pentagon. It has 5 sides. If a polygon is regular, that means that these are polygons which are both equiangular and equilateral. So let's look again at the hexagon. No, I guess I did not draw that one that well. Let me go. Oh, just a minute. There we go. So let me try that again. So let me draw you. Here we go. Here we go. Here is a figure where all of the sides are congruent and all of the angles are congruent. So we would say this figure is regular. It's equilateral and equiangular. Let's go to the very next page. A diagonal is a segment that connects any two non-consecutive vertices in a polygon. So let's say we have a polygon like so. This is certainly not a regular one, but if you were to connect any two non-consecutive vertices, say these vertices or these, you would get diagonals. And we're going to name those diagonals. Let's say we have A, D, B, and C here. The diagonals in this polygon are segments DB and segments AC. And here's something that we're going to be using. The sum of the interior angles of a quadrilateral is 360 degrees. We knew that the sum of the angles in a triangle was 180. We've talked about that. But in a four-sided figure, in a quadrilateral, the sum of the angles is 360 degrees. That's all for today. Thank you for joining me.